continue to complete the square. Yesterday our problems were pretty perfect, weren't they? They were all perfect square trinomials that we were able to easily factor. Today they're not going to be as perfect, and we're going to talk about what to do if that occurs. Because more often than not, they're not going to be perfect square trinomials. Okay. So, when we first learned about factoring perfect square trinomials, we learned how to identify if it was a perfect square trinomial by taking half the middle term and squaring it, correct? That's how we knew we were able to do our shortcut factoring method. So if you look at this problem here, it says find the value of c that makes x squared plus 12x plus c a perfect square. It says then write the trinomial as a perfect square or a perfect square trinomial. So in other words, I want to know, what does c right here have to be in order to make this a perfect square trinomial?
36.
36. Half of 12 is 6, and 6 squared is 36. What about on this example? What does c have to be? Don't say it out loud. I want you guys to use your clickers here. You should know this from the other day anyway, what we were working on. The directions tell us to find the value of c that makes x squared plus 6x plus c a perfect square trinomial, perfect square, and then write the trinomial as a perfect square. So go ahead and find the value of c and then factor it. Good. Most of you agree that it's a. Looks like a couple of b's. So let's talk about this. What does c have to be a perfect square trinomial? 3. You need to take half of 6, which is 3, and 3 squared is 9. So c is going to be 9. So if you were to factor this, x squared plus 6x plus 9, it would be x plus 3, quantity squared, letter A, as most of you indicated. Alright, so let's talk about how this is going to help us. If you would copy down this problem onto your notes, x squared plus 4x minus 12 equals 0. Do we have a perfect square trinomial on the left-hand side? Half of 4 is 2, and 2 squared is 4. I've got negative 12. It's not a perfect square trinomial. I cannot factor this using the methods that we've learned. So I've got to try something else. Let's move negative 12 out of the picture. It's not helpful, is it? It's not part of our perfect square trinomial, so let's move it out. I'm going to add 12 to the other side. X squared plus 4x equals 12. Now, I still don't have a perfect square trinomial on the left, do I? No, I have x squared plus 4x equals 12. What do I have to have there on the left side in order for it to be a perfect square trinomial?
X squared on the 4x.
4.
Let me ask you this. What does c have to be to make this a perfect square trinomial? 4. Half of 4 is 2, and then 2 squared is 4. So let's add 4 there where c is. Now in algebra, we cannot just randomly add something to one side, can we? You add it to the left side, where else do we have to add it? To the right side. Let's also add 4 to 12. Not 14. Let me just stop and refresh what I just said. I had to figure out what I could put in here for c so that I have a perfect square trinomial. I can't complete the square unless it is a perfect square trinomial. If I add 4 here, now it's a perfect square trinomial. If I add 4 to the left side, I also have to add 4 to the right side. We have to add it to both sides of our equation. Now we should be able to do it just like we did yesterday. Let's go ahead and factor the left side, which is going to be x plus 2, quantity squared, equals 12 plus 4 is 16. Just solve it like we did yesterday. To get rid of a square, we would take the square root of both sides. X plus 2 equals, We also learned a couple days ago that if you add the plus and minus, or excuse me, you add the square root, you also have to add in plus and minus. And plus and minus goes on the 4. The square root of 16 is 4. So let's figure out what x is. To do that, I'm going to subtract 2. So I have x equals negative 2 plus or minus 4. So really I've got two answers here. The first one is going to be negative 2 plus 4. And the second one's going to be negative 2 minus 4. What is negative 2 plus 4? Negative 2 plus 4? It's 2. And negative 2 minus 4? Negative 6. We have two answers, 2 and negative 6. Remember, we can always check our answer. If you don't have a graphing calculator, grab one real quick. We want to graph. I'm going to graph this original equation. Remember, to type it into our calculator, it's going to have to equal 0, which it already does. So let's type in x squared plus 4x minus 12. Whoops, I need to go to y equals x squared this is locked up. Minus 12. I'm going to go ahead and zoom standard. Does our graph indicate the same solutions that we found?
Yes.
Negative 6 and positive 2. Okay, an easy way to check yourself if you have a real solution. Okay. Let's go to another example. This is multiple choice. We're going to do it together since we just started. So we have x squared plus 6x plus 8 equals 0. Do we have a perfect square trinomial? No. We don't. The 8 is not what we need. If we take half of 6, we get 3, and 3 squared is 9. So let's move the 8 out of the picture so that we can create a perfect square trinomial. And subtract 8. So I want to know what number could I put in there for C. That's going to give me a perfect square trinomial. That is 9. And if we add 9 to the left side of our equation, add it to the right side. It's going to be negative 8 plus 9. On the left side, let's factor. We'll have x plus 3 quantity squared equals 1. Negative 8 plus 9 is 1. We can solve this by taking the square root of both sides. So we have x plus 3 equals plus and minus. The square root of 1 is 1. So let's solve and find our two solutions. We have x plus 3 equals a positive 1, and x plus 3 equals a negative 1. Subtract 3. X is negative 2. Inside I could subtract 3 also. X would be negative 4. Let's look at another one here. How about this one? We have x squared minus 2x minus 4 equals 0. Is this a perfect square trinomial? It's not. So I'm unable to complete the square. So let's add 4 to the other side. x squared minus 2x plus, what do I need to put in there for c? 1. Half of negative 2 is negative 1, and negative 1 squared is 1. So I'm going to add 1 to both sides of my equation. If I factor it, I'll factor it as x minus 1 quantity squared equals 5. We can solve for x by taking the square root of both sides. So x minus 1 equals plus and minus square root of 5. Now, I picked this problem because 5's not a perfect square. That happens. I ask you to put your answer in decimal form. Sometimes I'll ask you to leave it in radical form depending on what type of solution they're looking for. So we could have 1 plus or minus the square root of 5. Could you also change that to a decimal answer? Okay. In your calculator, I would type in 1 plus the square root of 5. So approximately 3.24. And if I did, hit second enter to bring down that expression again. 1 minus the square root of 5. Negative 1.24. So far, all of our solutions have been real answers, correct? The next one that we're going to look at is not going to have a real answer. It's going to have an imaginary. Here's the next example. Go ahead and copy it down into your notes. X squared plus 4x plus 11 equals 0. Now I want to start by graphing this. So if you guys would go to y equals, shrink this up a little bit. And let's type in, what's in here? Whoops. Y equals, and we're going to type it in. We have x squared plus 4x plus 11. Go to graph. This problem never touches our x-axis, does it? Okay. Remember, we say this would have no real solutions. In other words, it has imaginary solutions. So we should have an I in our answer. We should have an I in our answer. So let's go ahead and try to complete the square here. Do we have a perfect square trinomial on the left? We don't, so let's get the 11 out of the picture. Subtract it. X squared plus 4x equals negative 11. What can I add to both sides of this equation so that it is a perfect square trinomial? Not 2. Half of 4 is 2. 2 squared is 4. Make sure you do add it to both sides. That's a common mistake. I'll see you will only add it to one and not both. So factor the left-hand side. X plus 2, quantity squared. Simplify the right side. Negative 11 plus 4 is negative 7. Take the square root of both sides. So we have x plus 2 equals plus and minus the square root of negative 7. Now, the square root of negative 7, that can definitely be simplified, can it? As far as an I can come out. We have a negative under our square root. We know that there's going to be an I in our answer. So I'm going to start with that. Square root of negative 7 is really the square root of negative 1 times the square root of 7. Square root of negative 1 is I. Now solve for x. Don't stop here. X is not by itself. I need to subtract 2. We have negative 2 plus or minus I square root of 2. Is this answer right here the same as negative 2i plus or minus the square root of negative 2i square root of 2? Is that the same thing? Definitely not. Oh, 7. Yeah, sorry, 2 to the square root of 2. 2 to the square root of 7. Thanks. Here we're subtracting 2 from this term, right? Here we're multiplying with something totally different. They are not the same. Don't do this. And you can leave your answer like this. If you have an I, or imaginary number, in your answer, I'm okay with you leaving in terms of a radical. I like for you to change the others to decimal for the mere fact that you can check your answer in your calculus. That's really the only reason. You could leave in radical form if the directions ask you to do that as well. Alright, so we're kind of looking at some different things. We're applying what we know about radicals, square roots, and simplifying. We're applying what we know about imaginary numbers. Remember, you can always check your answer with your graphing calculator to see what type of answers you're going to get. Now, the graph may not tell you a whole lot about your imaginary answer, but at least you'll know that it is imaginary. I do have some problems for you guys to practice tonight on page 288. 8 and 9, 12 and 13, 30 to 33, and 38 to 41.